this is a lecture I've given sort of a few times before during the last weeks, and I sort of changed the title last minute because Gen AI in Teaching: A Miracle in the Works is not in the works anymore. It is a miracle, actually. So that was scratched out yesterday. This is about a course I've given for some years now. It's an introductory course for data science and computer science students teaching mathematics, transitioning from high school and entering the world of machine learning and optimization. So first, let's just view the state of the art as of approximately today. So what blew me out of the water during the last 6 weeks is the advent, or at least the thinking models, which has been present for the last year, but they're in my view, they've become incredibly powerful during the last 6 weeks. And Opus 4 came out May 22, which was this last Thursday. I had occasion to play with it on my way back from Copenhagen in the train. And then we have the Google flagship Gemini 2.5 Pro, which actually released their flagship model like 2 weeks before the Google I/O at advent a week ago. And the interesting thing about Gemini 2.5 Pro is that learning is actually built into it. There are pedagogical principles built into this behemoth of a model. So Google had a project called Learn LM, language models for learning, which is now built into Gemini 2.5 Pro, and they released a set of very interesting prompts here. So Google DeepMind, they sort of guide you through the way to use the Gemini 2.5 as a tutor, how you should prompt it. But the pedagogical principles and so forth for learning are actually built into the model itself. Not only is it really, really good for doing science and math, and I would argue also that this it certainly has a permanent place in dialogue about research too. And their hallucination is a feature, it's not a bug, I would say. So here you can browse through the prompting techniques that utilizes the built-in learning principles in this wonderful new model. Let's see how we. So one funny thing, I'm sort of a programmer at heart. I like to program and code. So when I applied for Python API application programming interface access, I had to upload my passport. So these models are they're serious business. They're well guarded and so forth. You can't get API access unless you if you're a foul player or something like that. So that's just a funny story. I had to upload my passport. But the point to take away from this now is that actually pedagogical principles are built into the new models. I also think that Claude Sonnet actually has pedagogical principles and learning built into it. So just a short list here. How did we actually get here? Well, in my view, we got here through neural networks in 2012, where neural networks were actually, they were not invented there, of course. That goes back way back. But the utility and the applicability of neural networks were realized in this context in 2012 with AlexNet, done by Alex Krzyzewski, Jeff Hinton, and Ilya Sutskever. They actually won this wonderful ImageNet competition, which was had been going on since 2005. By recognizing objects in images. So that was the first neural network that blew the competition away, actually, in 2012. And well, Jeff Hinton won the Nobel Prize in Physics, and Krzyzewski is sort of the unsung hero in this story. He was the programmer that actually programmed the graphics cards painstakingly in doing this. And Ilya Sutskever went on to co-found DeepMind in 2015 and is a celebrity inside deep learning now. So they all three went on to Google, and they got jobs there. They were hired by Google afterwards, and Google experimented with embedding text and words into high-dimensional Euclidean spaces. And the first, in my mind, useful vector embedding here was invented in 2013 by Google. Actually, that was a breakthrough that sort of led the way to many other breakthroughs. So I think I can't remember the dimension of the Euclidean space, maybe 700-800 or something like that. So you associate a vector in a Euclidean space, a unit vector, you usually do a word or a sentence capturing the semantic meaning. And then, of course, attention is all you need. Got away in 2017. People probably didn't realize at the time that it was a major breakthrough, but it transformed the world, and the transformer model was introduced in there, and it's omnipresent now in everything we're doing in this generative AI work. So GPT-1 was the first language model in 2018 that OpenAI, and of course, all hell broke loose in 2022. With ChatGPT, November 30th, 2022. So, and Gates has he has a wonderful blog entry where he explains about that and how OpenAI approached him August 2022, and he challenged them with a biology advanced placement test, and he was just completely taken aback by this. So Gates was converted in August 2022 with GPT-4 model here. Now you can't give a talk on generative AI without having at least one quote from Geoffrey Hinton. So this is the obligatory Geoffrey Hinton quote here. So actually, Computer History Museum in California and Google went into an agreement just a month ago about open sourcing the original code from the LXNet here. So this is an announcement they gave like a few months back that now they're releasing the LXNet source code, and they are sharing it with the public in a wonderful exhibition at the Computer History Museum close to Google, which I hope to see this summer. But if my wife wants to join me, I'm not sure. But so that's sort of the history behind things. And of course, Jeff Hinton, always being pointed, says that Ilya thought we should do it, Alex made it work, and I got the Nobel Prize. Right. So deep learning royalty, the point is that we really don't know why this works. It's a total mystery. I mean, mathematically, it's extremely elementary, in lack of a better word. Things that we're using matrix multiplication, exponential functions, and maximum of numbers and so forth, but it's concocted in a very, very ingenious way. So here we have deep learning royalty. We have Jensen Huang here, CEO of NVIDIA, and an older version of Ilya Sutskever. And Sutskever says that the thing I find most surprising is that it actually works. Okay, to come back to my course, I like to start with a slide called No Bullshit Gen AI, where this is a picture from August 2024, when I'm teaching my course, Introduction to Mathematics and Optimization, and the students, they approach the blackboard and they take pictures of the blackboard, and it gets flawlessly transcribed into LaTeX here. So this is AI Studio. I hope some of you are familiar with AI Studio. It's a wonderful tool. You get to use the cutting edge Google model, which is now Gemini 2.5 Pro. They're releasing the newest version probably in a week with this more focused deep seek property. So you see here you have the picture of the blackboard. Please generate source code for LaTeX expressing what is written on the blackboard. And I have no idea, and I consider it a total miracle that it's able to pull this off. I'm not going to compile the LaTeX code. You have to take my word for it that it actually works here. But this is really amazing. And please follow me in this chain of thoughts. I mean, this also poses a threat. So now, no textbook, no copyrighted textbook is actually safe here. You can crowdsource this process. You can take pictures of the books, and you can translate them into LaTeX. You can make the numbering work, and voila, you have semi-illegal open source version of all books that you want, and you can upload them to Gemini 2.5. You can prompt it, and you have a tutor that can solve every or most exercises in undergraduate and beginning graduate curricula. I consider that a bit of a threat, actually. I'm not too happy about it. So this is me standing teaching Introduction to Mathematics and Optimization. I was very enthusiastic about it when it came out, because I saw that the weaker students actually took to it and they woke up, which was, I considered quite interesting. I'm interacting with the students once a week in smaller groups, and they tried to cover their screens so that I could not see what was going on. But we quickly found out that this wonderful tool, ChatGPT, just came out, and they asked me if they could use it for the exam. And yes, of course you can, I said. But the university pulled back like a month later and said, no, you cannot use it for the exam. And now we have embedded in the course description, we have saying that you're supposed to explicitly mention in the course description if you're not allowed to use it. If nothing is mentioned now, that's the end of it. Then you are implicitly allowed to use generative AI at the exam. That might change. So I started in the fall of 2023, where I integrated I tried to teach the course here, and this is the meager homepage from 2023, and I had the first chapter of my notes, the language of mathematics, and I had the idea that students knew how to prompt, which I was completely wrong about. So in the following year, I had to change that. So I had to change the title of the first chapter to, just a sec. I had to change the title of the first chapter to the language of mathematics and prompting. I soon found out that beginning students, they didn't have, probably because they're not used to the precise mathematical language, they didn't know how to prompt precisely. So I had to embed prompting in the course notes, which I did. So you start by introducing prompting here. So here is an example of a prompt. This already seems very old. This is from August 2024. Please give feedback on the mathematics contained in the latex below in triple quotes. Emphasize logic and precision. Now you get to pick your language model down here. We're in Europe. We should pick Mistral here. So now we have Le Chat here, and let's see if we can fill out this. That might be, how do we paste this? Now we paste in the prompt, and Mistral is extremely fast. I don't know which model it uses, but it gives reasonable feedback and acts as a local tutor for the student, and gives advice too. So this is something I had to embed in my notes in order, because I realized that the students were very challenged when it came to precise mathematical language and embedding the precise mathematics question inside prompting. This is also useful for teaching hairy concepts in the beginning, like the definition of a continuous function here, right? So if we go here, we have this incredibly, well, in lack of a better word, ugly definition of a continuous function in a Euclidean space, right? So you go to the LLM and you prompt it and say, well, just prompt, I find the definition below quite challenging to understand. Please explain it to me patiently with lots of example. Test me in the end. What should we use? Let's use the newer version of Claude here and see what we can do about it. So here is the newer version of Claude, which is Claude Sonnet. We pasted the prompt in, and let's see what Claude does here. Okay, simple examples, discontinuous functions. Okay. So I think also Claude 4 has some pedagogy and learning built into it. This is the new version of Claude that just came out less than a week ago. You get the testing of your understanding here and everything. So take your time thinking about these and let me know your answers. I'll help you work through any you find tricky here. Not sure. So yeah, and I also did prompting during lectures. Actually, it spices up the lectures when you prompt during the lectures too. That was also a takeaway. But the main point here is that I actually had a project going on implementing a course chatbot on Azure, which is the Microsoft cloud. That was a major undertaking, and I had to engage 4 computer science students or 5 computer science students here. It was a very interesting project, so I had to chunk up my course notes and do a retrieval augmented generation chatbot here. So first of all, I have to say this was done in collaboration with 2 very inspiring people at the management department, Carsten Bergenholz and Oana Voculescu, who did a first version of this in a philosophy of science course in the spring of 24 with many students. And I should also add that our project is supported by the IT University in Denmark and the Aarhus University too here. So I had to enlist a segment of incredibly talented computer science students. So having taught the course, I had access to top of the line students here, and these are extremely gifted. I met Felix in the canteen. I asked him, "Do you know any Azure?" And he said, "Yes, sure, let's do it." And we sort of gathered on this journey, and we implemented the retrieval augmented generation chatbot down here. And also, I mean, Felix and Casper, they have a company together, very enterprising fellow. I think that Timothy here and Oliver, they also have the company, and Daniel is actually also incredibly gifted programmer who's just landed a great job. So we did a retrieval augmentation generation chatbot. So that means we chunk up the material, the textbook, semantically, and chunking is sort of a science. So you have to semantically, you have to chunk it up logically so that each chunk contains a well-defined section of the mathematics textbook. And then we use the vector embedding. We embed each chunk as a vector, high-dimensional vector. Actually, in this case, it's dimension 3000. And so we hope that this high-dimensional vector captures the meaning of the mathematics in the text chunk, which worked out pretty well. Let me just walk you through the content of my course here. So we have 9 chapters. We have the language of mathematics and prompting, which is an introductory course or chapter on set theory and basic logic and functions and so forth, and also introducing proofs. Then we have linear equation dealing with Gauss elimination and so forth, and matrices. And one thing that stands out in matrices is I emphasize positive definite matrices and positive semi-definite matrices because I have a later chapter on convex optimization. What is optimization? Contains a bit of linear programming and the Fourier-Motzkin elimination method. And Euclidean vector spaces, that's the crucial chapter of the book, containing, for instance, the perceptron algorithm and least squares and so forth. And then we have convex function leading up to the last chapter, convex optimization, which has the it's a very interesting optimization algorithm also for machine learning. So right. So the chatbot statistics, how did this work out? Well, the students engaged at all times of the day. Actually, it was I would consider it a success. Actually, it was very well received, and I was pleasantly surprised by this median chat attention span by a little over 4 minutes per chat. We had timestamps on the prompts, so if the first prompt was timestamped, and the last answer from the system was also timestamped in a thread. So this median chat attention span I consider very interesting, actually. So the student actually engaged with the chatbot. Activity timeline, very human student activity. When you have mandatory exercises, the activity is high. So there's not much to say about the activity timeline. So let me see if we can do some examples here. We have this system is in Danish. So I hope you will see if we do understanding the Hessian. Let's see if that works. So here we have an example of a student interaction with the chatbot. So the student is reading through chapter 8 and needs help understanding it on an intuitive way here. So the chapter 8 is on Hessians, and the students is guided through the chatbot. Maybe the student wants to understand the gradient in one dimension, and it's answering very patiently here, and so it's almost like ChatGPT, but it's grounded in the notes. So this grounding procedure is not entirely easy, but maybe we can return to that actually. So this is a model student interaction with the chatbot. So we have some project going in 2025. Let's see. Let's just make an experiment. It shouldn't be boring, right? Let's see if we can make this work. This is a linear algebra course going on right now. This is maybe let's see. Maybe I cannot expand this. Let's see. How do we do this? This is, I'll have to postpone this demo. This is a course in Danish. It also responds in English, but I'll have to postpone this. But it's very patient. And this was done by chunking out different files like PDF files and so forth. I have this interactive HTML book, which was easier to chunk up, which I did myself. Here we had to chunk up existing course material, and I think it went pretty well. One thing I might add, it makes a huge difference which model you actually use. So here we went from 4.0 mini to GPT 4.1, which made a huge difference actually in the quality of the interaction. The evaluation, I have evaluations in Danish here. I have text. It's probably not that helpful for an international audience here, but I have some numbers to show for it. Most of the evaluation, most of the student feedback was quite positive. And so what do you do when you're sort of geared towards machine learning? You go to Hugging Face. In Hugging Face, you have the cutting edge sentiment analysis model, which is actually a lot better than ChatGPT when you asked it about it. So you go to the Twitter sentiment model, which is trained on 140 million tweets in very many languages, and you what's the sentiment of the student answer. So we had pretty positive experiences, 71% positive respond, 17% negative, and 12% neutral. I checked them afterwards actually. There were only 78 responses to check. So, and it agrees pretty well with this model up here that I ran through Python. So that was fun, something to take away. I have some material here on AI generation and co-grading, which I will not share with you now. That involves some experiments with Google Gems where you can cook up with a nice system prompt. You can cook up a co-grader helping you grade exams. Of course, you're grading your exams yourself, right? But you can ask for advice, and a system prompt in this case is a rubric. And also I did some experiments with generating exam questions, which were also very encouraging. And that was in December. And with the newer model, it's certainly, I haven't tried it out there yet, but it's certainly something to try out. It's gotten a lot better. So that marks the end of my talk, and I'm willing to take your questions, please.
Okay, I think that we can just have the question after the second presentation. Is this okay for you?
Okay.
Okay. Yep. And I have just a pair of questions, but as we just met before, we can just listen to the second presentation and then open the discussion with the questions. Okay. So I leave the floor to Professor Rune Nyrup, and the title of the presentation is A Good Explanation, a Philosophical Foundation for Explainable AI.
So thank you very much. This is a talk where I'm going to explain a little bit about what I do as a philosopher who's very interested in explainable AI. I have a background in philosophy. I'm actually a colleague of Niels's. I teach computer science students AI ethics and philosophy of science here at the university. So I'm at the same department as Niels, but I am not a computer scientist. I'm a philosopher. So I'm going to talk a little bit about this topic here, particularly what is a good explanation and why is that important for the way that people are working with explainable AI. So a lot of the motivation from my work comes from the past 10 years or so. Not only has there been this evolution in AI that Niels described, there's also been a parallel evolution in AI ethics. So starting in about 2014 and then peaking around 2018, all sorts of organizations from all over the world have been publishing AI ethics guidelines or recommendations of various sorts. So here is, for example, just some data from a review where they found 200 of these. And as you can see, you have government institutions, so typically parliamentary committees or governments putting out sort of national strategies for AI. You have private corporations. A lot of the big tech companies have been putting out their own reports or guidelines for AI ethics. NGOs, academic organizations, even religious institutions have been putting out these AI guidelines. I think it's the Vatican, if I remember correctly. They also have a report about their recommendations for AI ethics. So there's been a boom in all sorts of organizations trying to say something about how do we create ethical AI, or sometimes people call it responsible AI or trustworthy AI, but it's sort of roughly the same thing. So if you look at these recommendations, I'm here just using the data from the same study here, there's some robust patterns in the kind of issues that are brought up. As you can see, the vast majority, so out of 200 guidelines that they found in this study, the most commonly cited themes have to do with transparency, explainability, and auditability, and closely related issues around reliability, safety, security, trustworthiness, and then also justice and fairness is up there, and then you can see all the rest of it down there. So it's something that there's been a lot of discussion about. There's a lot of people in the governance space, if you will, are putting out recommendations for how do you create ethical AI, and almost all of them highlight explainability or something closely related to it as one of the most important topics. So that's what I'm interested in. As a philosopher and someone who's engaging in AI ethics from a philosophical point of view, I'm interested in what do people mean when they put out these kind of recommendations? What do they mean when they say we need explainable AI? Does that have a well-defined meaning? Oh yes, this is just one example. So this is a report that WHO put out a few years ago, just to give you one example of how this looks. So they put out a big report on ethics and governance for AI, and like many other organizations, one of the things they do is they have a chapter on key ethical principles. And so this is an example where they had a principle mentioning transparency, explainability, and intelligibility. And if you look into the chapters, you can find formulations like the one that I've quoted here, which says that AI technology should be explainable to the extent possible and according to the capacity of those to whom the explanation is directed. Now, if we want to be serious about doing AI ethics, it's not just pretty words we're saying, we should ask ourselves, well, what do we mean when we say it is explainable? To what extent, what does it mean to say that something is explainable to a certain degree, to an extent possible? What does it mean that there is a capacity that's relevant to an explanation? We would like to define these things a bit more clearly. If you look at these reports, maybe unsurprisingly, you don't find these explanations. You just find sentences that sound plausible. So a lot of my work is trying to engage with this kind of more high-level talk and try to see if it can be given some clearer definitions. So this is, however, not just explainable AI. I think most of the people on this call will be familiar with this. Explainable AI is not just something you find as a concept in governance reports and in ethical discourse. It's also something that's made it into computer science. So this is just a selection, more or less randomly selection of papers, just to illustrate that this is a very hot topic of research also for computer scientists. So computer scientists are trying to create techniques or tools or methods that in some sense or another should give you explainable AI. As you can see, it's being published in some of the top venues, including Nyrup. So this is a very serious area of computer science studies. Just to give you one example, again, I think many people will be familiar with this. This is one very popular method called MIME. So to give a Lime explanation, you have a data point you want to explain. So that's marked by the fat red cross. And in this is a sort of a toy example here that they have from the paper. Where they say, well, suppose that the real decision boundary is the red area, but that's too complex for us to really grasp. So instead, we sample some points from the model, then we weight them according to how close they are to the point we want to explain. And then we train a linear classifier on those data points we've sampled from the model. And then we generate explanation based on this more simple explanation, which is a good approximation of how the model behaves close to the point that you're interested in. And then if you have the simplified model, you might be able to use it to highlight the pixels that are given the most weight in the model. So you can say that an explanation for why something is classified as a wolf might highlight the pixels where there's snow in the picture. And that's supposed to give you some insight into why the model classifies the picture in that way. Or if you have tabular data, you might highlight the features that had the highest value. So if you get a prediction that a patient has flu, you create a Lime explanation, and then you highlight those features that had the highest positive or negative weight in this linear classifier. So it might say that the explanation for why this patient is classified as having flu could be that they have a sneeze, they have a headache, and the negative evidence for it was that they didn't have any fatigue, but so the explanation will highlight those factors. So that's supposed to give you some kind of insight. It's a phrase people often use, or some kind of reasons for why it classified that way. Now, when you read these kind of papers, it's still not clearly defined or explicitly defined what do we even mean by an explanation here. There you'll find some ideas around why it's important, but being computer scientists, they will focus on coming up with a computational tool and showing you how to do that. So this is just a slide to show that this is not just sort of pure research, it's also being sold on the market, implemented in systems and being sold explainable AI solutions. So it's something that exists out in the real world that you can bump into. Okay. There is a debate within computer science and data science, however, about this explainable AI. There are a lot of people who are skeptical that it's doing anything useful. And so there's an internal debate around how useful it is. So some people are very skeptical. Cynthia Rune basically thinks that you should never use a black box model, and it doesn't help if you put on one of these explainable AI techniques. You should just use interpretable models whenever you can. Zachary Lipton has also expressed some frustration that the concepts aren't very clearly defined in this debate, and he's been trying to contribute to doing that more precisely. I talked to a PhD student working on explainable AI, and he said he never reads a paper these days without there being a section that says, we don't actually know how to really measure what a good explanation is, but we'll try to do it anyway. So it's something that people are aware of within the literature, that there are some methodological problems around how do you even measure and explain what a good explanation is. So this is where I come in. So what I like to do and what I like to think I do in my work is to provide some foundations for putting this field of explainable AI on a more solid foundation. A lot of the papers, including some of my own previous work, talks about frameworks for explainable AI. I've gone off that term a little bit. It's become a bit of a cliche. And to me, a framework sounds a bit like a recipe. I don't think I'm giving people a recipe they can just follow and then they do the right thing. So I'm started to say, instead I do foundations. I sort of create some stable grounds that others can then build on top of, but I'm not giving you recipes for how to do it. I'm sort of trying to make sure that the basics are defined in a rigorous way, but then there'll be lots of other work for people to do on top of the stuff I do. But I don't have a rigorous definition of what the difference between a framework and foundations is. That's just the word I prefer at the moment. So what does this look like? I draw some ideas from philosophy of science, although I work a lot on AI ethics at the moment. My training is in philosophy of science, and philosophy of science is a field where people have been debating what an explanation is and coming up with various theories for a number of decades now. So there are some pretty well-developed theories within this field reflecting on what explanations look within the sciences. I think we can draw a lot of inspiration from that field to try and get clear on what we mean by an explanation in the case of explainable AI. So, I say 3 ideas, that should say 4 ideas. So there are 4 ideas from philosophy of science that I build my approach on. So, so it's explanatory pluralism, the fact that explanations are idealized, more theoretical idea that explanations are communicative, so it's called the communicative view of explanations, and then what's called an inferentialist view of understanding, and I'll walk you through what each of these mean. So, okay, so this is the point about pluralism. One observation that's been made in philosophy of science is that it's very often possible to give many different explanations of the same phenomenon, and all of those explanations are good explanations, even if they look very different. So here's just an example from biology. If you ask, why is a cheetah able to catch a gazelle? You can give many different kinds of explanations of this phenomenon. You can give a physiological explanation where you talk about how the muscle structure and the bone density of a cheetah enables it to reach very high speeds and navigate at those high speeds quickly enough to catch a gazelle. You can give an ecological explanation saying that on the African savanna, there's an ecological niche that is filled by a very fast predator like the cheetah. You can give a phylogenetic evolutionary explanation, so where you track the different speciation events that historically led to the emergence of the cheetah. And you can maybe even give a molecular genetic explanation where you really go down and look at how the DNA and the genes, how they create the body and the running capabilities of the cheetah. And the point is, these are all completely valid explanations. They are, in some contexts, good answers to the question, why is a cheetah able to catch a gazelle? But they're obviously very different, giving you very different kinds of information. And depending on the context, different kinds of explanations seem to be the most appropriate one. So that's one observation about explanations. Explanations are plural. There are many good explanations of the same thing, and it depends on context which one is the right one. Another observation is that explanations are idealized. So by that, we mean that they are selective and simplified representations of the thing you want to explain. The whole reason we give explanations is that we have some very complex phenomenon that we can't understand directly. But then if we give some selective and simplified representation, some information, and the idea is that by giving sort of targeted information that highlights the key features and maybe simplifies them a bit of a phenomenon, then it becomes easier to understand it. And so lots of physical models work like this. They make simplifying assumptions, for instance, that the molecules in a gas are spherical, and then you can derive some equations that in some contexts are good enough. Even if they don't capture the full complexity of phenomenon, they give you the information that you need in order to understand it and think about it reliably. Okay, so these are some general observations about what explanations are. If we want to start theorizing a little bit more systematically about that, what that means, one idea that I find very helpful is to adopt what I call a communicative view of explanation. So a communicative view of explanation is takes the basic phenomena explanations are communicative acts. So where you have some communicator, which is the orange stick figure here, S in the text, that conveys some information about an explanatory target that you want to explain to an audience in order for that audience to obtain a better understanding of X. So in other words, we should think of explanations in the first instance as speech acts, as communicative acts, where you have an communicator, an explainer that conveys some information to an audience. And the thing that makes it an explanation, as opposed to, say, a story or a question or other kinds of speech acts, the thing that is sort of the defining feature of explanations as a speech act is that they aim at providing understanding. So the point of this definition is then you sort of reduce away the concept of explanation. You just say whichever information that helps give an audience the right kind of understanding, that counts as an explanation. So that's the first move. The second move is then to ask what is understanding. And here I favor an inferentialist view of understanding. On an inferentialist view, understanding is defined by the kinds of inferences that you're able to make about the thing you understand. So defined formally, I write that someone understands a given phenomenon in a context to the extent that they're able to competently draw inferences about that phenomenon that are needed to achieve contextually salient purposes. And the last point is a very important observation. What counts as a good explanation depends on context. And in particular, it depends on what we think it's important to be able to do in a given context. So here with the stick figure, playing football, you understand the football well enough in that context. If you're able to know what you're supposed to do with the ball, you're supposed to get it into the goal. That's the kind of understanding we're after in that context. And it's important because shifts in context can change what is the right kind of understanding you need, what kind of inferences that you need to be able to draw. So if I say in an ordinary context that I understand how a fridge, what a fridge is, I understand my fridge. Probably the kind of things we have in mind here is that I know I need to put my food into the fridge, and I know I need to turn it on in order to keep my food cold and to avoid it spoiling. So those are the kind of inferences I need to be able to draw when I say in an ordinary context that I understand my fridge. But if then my fridge breaks, I might say, oh, I don't understand this fridge. And now we've shifted to a new context where the relevant kind of inference is knowing how to repair it. And so the standard for what I need to be able to do in order to count as understanding has changed because we're now in a different context. If we put these ideas together, we can give a definition of explainability. I call it explanatory pragmatism for sort of various history of philosophy reasons. So I'll read it out to you, and then it might look a bit complex on the slide, but the idea is fairly straightforward. So I say that some entity, it can be a computer program or an AI model, is explainable by some explainer to an audience in a given context, to the extent that the explainer is able to convey information about the phenomenon to the audience, and this information should enable the audience to competently draw inferences about the phenomenon, and it should be those inferences that are needed to achieve the contextually salient purposes. So two things that are worth noticing here. First of all, I have relativized the definition of explainability to a particular communicative context that includes who is doing the communication, who is the audience, and what are the salient purposes. So in this way of defining it, there's nothing that counts as explainable simpliciter. There's nothing that's just explainable full stop. It's always explainable by someone to someone in a context. So that's the first observation. And the second one is that you can sort of, using this explanation, you can almost start from the back of it and start by asking yourself, well, what are the contextually salient purposes? Once you've found that out, you can ask yourself, well, what inferences does the audience need to be able to draw to fulfill those purposes? And then you can ask yourself, well, what information do I need to give the audience to give them the ability to draw those inferences? So you start from the purposes, and then you work your way back to find out what is the information you need to give. Okay, so what can you do with explanatory pragmatism? We can say something about what it means for something to be explainable. It's always relevant to an audience and context, as I've said. And we can ask ourselves, well, why is it that explainability is supposed to be ethically important? One lesson we can draw is there isn't any general reason. Again, that will depend on context. So it all relies on the kind of contextually relevant, the kind of assumptions you're making about what are the contextually relevant purposes. And you should make those explicit. If you want to claim that you've built an explainable AI system, you should make explicit what are the purposes that you're implicitly taking for granted when you make that claim. And I think it gives some practically useful heuristics for evaluating whether XAI is doing the right thing. I think I won't walk you through these examples in detail, but the first one I've mentioned already. You can start from the purpose and walk your way back to find the kind of information that will serve as a good explanation in this context. So you can think of different audiences. So in a medical case, for instance, you can distinguish between one audience, could be human clinicians, and here a plausible purpose is that they need to be able to detect if a model is making a faulty decision. So here, maybe the information you need is to figure out which factors made the greatest difference to a decision in order to figure out whether those are factors that are plausible in light of your clinical understanding. Hospital managers might need to make different kinds of decisions. Maybe they're not really interested in individual treatment decisions. They're just interested in whether this model is going to be performing reliably overall. So here it's more about whether the correlations that the model relies on and the causal structures that underwrite this reliability, whether that's likely to also be reflected at their hospital. Patients, again, might require different explanations again. To a patient, patients probably aren't competent to decide whether a diagnosis is the right one or not, but maybe they're more interested in whether the model are presuming certain kind of values around what kind of health outcomes are most important to their treatment decision. And again, other kinds of information might be relevant to deciding that question. I think you can also do it the other way. If you have an XAI tool that you think is working really well, you can start by saying, well, what kind of information does that give me? And then you can ask yourself, what kind of inferences does that allow a given audience to draw? And then you can start reasoning about what kind of purposes, what would this tool I've created be good for? And I think that's another practically useful use of this framework. Okay, final bit, which I'll go through, also not in a great deal of detail, is, well, there's often an assumption in the literature that explainability just is good. It's often just assumed that we should definitely prioritize having explainable systems. But it's worth asking ourselves, is explainability always an ethical good? You know, if you're being given an explanation by a human, sometimes the explanation can sort of be a little bit misleading. So if you're asking, why am I being moved from weekly checkups to a yearly review, and your clinical team tells you, oh, it's because your situation is sufficiently stable, that might sound like a good explanation, but it's also hiding something, or it's also making some things unclear, like what does it mean for something to be sufficiently stable? By what criterion are they making that choice? And there might be slightly different interests at play here. So when a patient asks for an explanation, presumably their interest is to make sure that they're being given the best possible health care that they can get. Whereas a clinical team, or maybe more at the level of the clinical system, they might be more interested in encouraging compliance, ensuring a fair and efficient use of health resources across all patients, maybe ensuring that the system is as efficient as possible. And different kinds of explanations might be good for different kinds of purposes. And so we should be a bit wary that when we're giving explanations, whose interests is it actually that we're prioritizing when we're trying to create good explanations. That's just another example. So there are case studies where people are looking, for instance, at the kind of explanations you can get on Facebook. And one of the things at least some of these studies show is that explanations seem to be often either incomplete or misleading, or vague in various ways that might be beneficial if you want people to trust that Facebook is doing the right thing, but might not be very useful for a user to figure out how their data is being used. And again, there could be some conflicting interests here. Another reason to be a bit worried about explainability is something that's called sometimes the illusion of explanatory depth. So it's a phenomenon that psychologists have studied where it turns out that often if you give people something that sounds like an explanation, they will often get a sense that they understand, even though that explanation is completely irrelevant. So one example of this is there was one study, the one on the right on this slide here, the seductive allure of neuroscience explanations. It turns out if you use neuroscientific terminology when given an explanation, people feel like they understand what you're talking about much more than if you're giving psychological, sort of more traditional behavioral psychology information, even if the information is completely irrelevant to the thing you're explaining. The mere fact that you're using neuroscientific words when you're giving an explanation gives people the sense that they understand. So there is some evidence from psychology that people's sense of understanding can be manipulated in strategic ways. There could be a worry that explainable AI could be misused in the same kind of way. And this is part of what people are sometimes worried about, that you can get an illusory understanding. So this is an example from Cynthia Rudin's paper, where you'll be given, if you ask, so this is a salience method, if you ask it to explain why are you classifying this as a Siberian Husky, it highlights pixels that are around the face of the dog, and that seems very plausible. But then it turns out, if you ask it instead to explain why is it classified as a transverse flute, it highlights the exact or almost the exact same pixels. And so there's a worry that people might overinterpret the explanations they get and feel like they understand something about how the model works, even if they don't actually being given anything useful to make that decision. Okay, so this is my penultimate slide. Part of what I'm working on at the moment in my research is to try and get clearer on what are responsible ways of using explainable AI technologies. See if we can define in more rigorous ways what how do the existing explainable AI techniques, to what extent do they represent their explanatory targets in an adequate way? Can we draw a line between the helpful simplifications? Remember, I said to begin with that all explanations are simplified, but can we have some criterion that helps us to distinguish between the helpful simplifications and the ones that go into more of a manipulative or even deceitful direction? And also this problem of there being different interests and purposes between different kinds of explainers and audience. So can we find any kind of principles for how we make sure that we are not in an inappropriate way prioritizing one set of purposes in favor of another? So thank you. Here are some link if you want to see more about the stuff that I do with my project here. Thank you.
Thank you very much for a very interesting presentation. Also because we talked a lot about explainability today and trustworthiness and so on. So I think that's your point of view is very, very interesting. But I would like just to ask if we have some question. I don't know.
I have a question, comment for Professor Nyrup. Very interesting presentation. Thank you very much. I believe that one aspect that needs to be further sought and researched is exactly the impact of explanations on the different kind of users, and probably I think that one line of interdisciplinary work is how to design also social experiments that can help us understand better what are the different factors at play. For instance, to understand, to watch to what extent an explanation for a certain purpose, for a certain audience, is a right simplification or is some sort of manipulation, or whether there is work that we have done on understanding whether interacting with the explanations, the level of trust of the human counterpart raises or diminishes, or how it is modulated. So my question is, don't you think that it would be needed to somehow strengthen the relationship between moral philosophy, cognitive sciences, and AI science to unravel this new generation of social experiments that can let us understand better this big question?
Yes, this is my very quick answer. I definitely think that at the end of the day, figuring out how it works in practice, measuring whether it works in practice as you expect it to, is going to be key. I definitely don't think that this is one of the reasons why I don't like talking about frameworks and recipes for explainable AI, because it makes it sound like it's something you can sit, in your office and work out on a piece of paper. And at the end of the day, you need to go out and see if the actual users you're going to be delivering these explanations to, does it actually help them do the things you think are important. I do think the kind of analysis I propose here can be helpful for that project as well. I mean, first of all, it highlights that you always need to be very explicit, and you need to think about what is the purpose you want to support here. So there are people doing in human-computer interaction and design studies. They do user studies. It's not always clear why they pick particular metrics to measure. So I think getting more clarity around what is it actually we want these explanations to enable people to do in relationship to trust, I think is an interesting one. I don't think we should always say that the aim is to get people to trust the system. I mean, they should only trust the system when it works. So we need to figure out, how do we give explanations that allow people to trust it when they should trust it, but distrust it when it doesn't work reliably.
Absolutely, yeah.
Yeah. So yeah, and I think there's also some worries about how do you generalize. So suppose you do a user study, it turns out for this particular group of users in one context, it does seem to help them use the system more reliably. How do you know, how can I generalize that result to other contexts, other user groups? I think being more explicit about what it is you're trying to achieve, how the information you're giving them is supposed to support their reasoning, would also help create a more robust theory for generalizing these kind of results. But I mean, the empirical work is definitely crucial, and I don't want to suggest that you shouldn't do it.
Thank you.
Other questions, observation? I just some comment. Okay, I strongly really agree with this idea that we need really a framework, and in this framework we should really use different competencies. At the moment, I think that we have really a very high number of papers discussing about how we can really explain the model. But most of the time we don't care about the final result of this explanation. And that is actually what happens normally. But also because most of the time the different journals publish papers from different competencies, and we have always a partial view of the problem. So this is actually the reason why I need really to have some sharing competencies just to really faced with this type of problems. Just a comment. You talked about also ethics and explainability. Can you clarify why don't you think, or probably just explain better why explainability is not so relevant for ethics? I just
yeah, sorry if I said that. I haven't expressed myself clearly. The kind of so in the beginning I showed you some of these reports about ethical guidelines that are being published by companies and governments and other organizations. Because they are more sort of policy making tools, they're not academic reports usually in most cases. I don't think what they're saying is false. I just think it's too vague to be really deeply helpful. I think there is some work, it's sort of the kind of work I do. I see myself as trying to become more precise about the things that sound plausible and probably correct that is being expressed in these reports, but trying to get it more precise that it can actually be useful to create things that work better. So it goes from just being nice sounding words that politicians produce to something that academics and developers and legislators can put into practice in a more rigorous way.
Thank you. Just a question for Niels. Okay, I just appreciate a lot your presentation, and because really it's a very good example of the use of generative AI and in teaching. And I would like just to have from you some consideration about In your opinion, there is some improvement in the learning process of the students. So the final result that we have in terms of learning outcome from the students, in your opinions, this approach can really obtain a better result in the terms of learning outcomes?
Yeah, that's a wonderful question. It's difficult to measure, right? And I don't have any numbers backing it up, but my experience is that the students, at least, I mean, the good students, we can do anything with. I mean, they're always going
I
to be
agree
good,
with you.
right? Yeah. So, but the
That-
middle segment and the lower segment, we can probably bring them back to life and make them engage with the material in a more interesting way, because we all know from our experience also doing research, then you sometimes get stuck. And the reason I started this in the first place is that it's a wonderful tool to get you going when you get stuck in the first place, because you have a partner 24/7 that you can have a dialogue with. So that was sort of my initial idea, that once you get stuck, you always have a partner. And hallucinations, unless they're completely outrageous, they mean less in this context. Also, when you research, you hallucinate 90% of the time, right? So it doesn't really matter that much. So, but I don't have any numbers to back it up. And my worry is now, looking forward, is that the models are so incredibly good now that you can upload your teaching material, and the models are so good that they can stay inside the confines of the teaching material and in flawless logic answer any exercise that the student asks about. So I don't know what we're going to do about that now. Certainly, we cannot allow generative AI at written exams in any form whatsoever. That's my opinion now. Had you asked me 2 months ago, I would have said, oh, yes, that's a great tool for the exam too. Now I am not so sure. I mean, so the recent thinking models are really, really good.
Yeah, but I just asked you because I think that's one of the roles that we have in terms of knowledge hub inside the SQU Alliance is just to really consider this aspect of generative AI in learning and teaching, and just to understand if these tools are very useful or how we can use these tools.
Yes.
And
Yes.
and as you just mentioned before, it's very hard just to really find a measure of the utility of these tools. I read a number of papers. I am not an expert in this field, but I read a number of papers in which, of course, when you talk about generative AI and generative about AI, the people just claims that this can be very useful tools just for really tune the learning process on students. But on the other side, you have the other problem that sometimes the students really use too much
Oh, yes.
tools and
That's true.
lose really the way to really develop the critical view about something. So it's not
That's a
easy
good point.
to find
Yeah.
something to balance this opinion.
Oh,
And
incidentally, if I may interject a question for Rune and also you guys, in industry, I think Anthropic is the company furthest ahead with explainable AI. They have actually people hired for it, and Google and OpenAI not so much. So do you know, Rune, do you know anything about the industry, how far ahead they are with this research?
I have to admit, I'm not up to date on exactly what that landscape looks like. Maybe others know more, closer to the technical side of things. My impression is that more of the advanced stuff is being done at universities, and at least maybe that's not so much the big research companies, but more sort of applied companies, that they tend to use just Lime or Shep off the shelf in a fairly naive way. But it might be that so I think the kind of so what people have invested more in is what's called mechanistic interpretability. That's sort of the thing that's very popular at the moment. and some of that is related to safety issues. So if you
Yeah.
understand what neuron clusters are driving certain kinds of behavior, you
Okay.
can sort of suppress those neurons a bit. If there's a cluster that corresponds to being very rude to the person, you can
Yeah.
suppress them.
Oh,
I mean, and people worry
incidentally,
about obviously
Rune,
misuse
have
of
you heard about the welfare of the models?
welfare. So sort of, are they having
Just like animal welfare, you have model welfare. It's not even a joke. I think Anthropic has hired people, one person in that segment.
Yeah. I know people who work on this problem, and it's
Really?
fascinating.
Okay, I see. Okay.
It is fascinating.
Yeah.
Though
Okay.
extremely hard. But
Yeah.
I know
Yeah.
there's a researcher at LSE, Jonathan Birch. He's a philosopher who has written a lot on animal welfare, and so he's done a lot of work providing evidence that shellfish, like shrimps and lobsters, that they can feel pain. And he's become convinced that we should take this problem seriously for large language models. I mean,
With
he's
the
not saying,
models.
yeah,
Really?
so
Okay.
he's not saying
Okay.
they definitely can feel pain, but he's saying
Okay. Right.
running out of good arguments to definitely
Okay.
just
I
dismiss
see.
it out
Yeah.
of
Yeah.
hand. We should
Mhm.
actually look at this seriously. So there are serious people
I see. Okay.
doing work on this,
Mhm.
not as a joke, although it sounds
Okay.
really weird when you say it.
In any case, in industry, actually, there is some interest, of course, about explainability. I'm working in fault detection with some company, and they are very, very interested in understanding what is the causes, of course, just to produce the fault. And you have just to apply some explainable approach just to give really the information they need. Most of the time they are interested, of course, in accuracy, but they're very interested in the root cause analysis. And you can really work along this direction by using some explainable tool just for the AI. I don't know if we have other questions or observation for Niels and Rune. Otherwise, we just going to close these 2 days of the symposium, and I'm very just happy about these 2 days because we started to talk about some research activity on AI in the different universities. I really appreciate a lot the presentation we had. Unfortunately, we didn't have so much time just to have interaction, not only among the panelists, but also with the participant. But I strongly believe that this experience was very interesting, at least for my point of view, and I hope that we can repeat in the future some experience in a similar way. Also because if we have just to create and we want just to make sustainable this alliance, we have to create connection between the researcher. This is the main aim that we have in our mind for the alliance. We talked yesterday about the objective of this knowledge hub on AI. Our dreams is just to have some probably at least double degree in the future, but also to have the possibility to think about new programs in the Circular U Alliance. And another dreams is just to really have the possibility to apply jointly for some common collaborations in research. These are the way to really create this collaboration between the single universities and to have in some way the sustainability of the alliance in the future. I don't know if you have comments about the structure of the symposium. If you have some feedback, please let me know, and in such a way that we can really improve in the future. And if you just consider this experience interesting, of course, we will try to organize other symposium in the future. In terms of generative AI in teaching and in research, we are launching a survey about the use of generative AI in teaching. I just tell this to Niels because I would like just really to collect all the experiences we had in the Alliance in such a way just to discuss about the use of generative AI, but also to promote very useful experiences to other groups and to other universities. So we will start with this survey in the next days, and I hope just to receive some feedback from all the researchers involved in the use of the generative AI. Thank you very much to all the speakers, to the attendees. I don't know if Miroslav wants just to close the section since the organization of this symposium was in charge of the University of Belgrade, that is co-supervising this knowledge hub with the University of Pisa on AI. So I leave the floor to Miroslav for the last closing word.
Okay. First of all, thank you all for being part of AI in Circle U over the past 2 days. We've had some really great discussions, shared great ideas, and hopefully started more than a few new collaborations. Artificial intelligence is a complex topic, but what makes it exciting is the way it brought us together. In this symposium, we all come from different backgrounds, disciplines, and countries, but we share the same vision of the future. Big thanks to the University of Belgrade and the organizing team for making all of this happen. Let's stay in touch and keep conversation going until we met in person. Thank you once again.
Thank you again. Just we can close here.
Okay.
Bye-bye. Thanks again.